Good morning, everyone. In this session, let us continue the last session class, that is MINMAX algorithm. We already discussed what is the MINMAX. MINMAX algorithm is a backtracking algorithm where it backtracks to pick the best move out of several choices. Generally, MINMAX strategy follows the depth first search concept. Here, we have two players, one is min, one is max, and the game is played alternatively between them. That is, when max made a move, then the next turn is of min. It means the move made by max is fixed and he cannot change it. And the same concept is followed in DFS strategy. That is, we follow the same path and cannot change in the middle. That's why in min-max algorithm, instead of BFS, we generally follow the DFS. So here, let us see some of the important points regarding to this min-max algorithm. The very first point is, it is a backtracking algorithm. One important point is, it is a backtracking algorithm. Why we are saying the backtracking algorithm? Why? Because we are calculating from root to leaf node. We are going to calculate root to leaf node. That means, and we are going to start at terminal. Generally, terminal, we will start and calculate the values at leaf. Calculate values at leaf, and then we go to the root. Okay. The path at last we follow is from root to leaf node. Okay. As we are starting from the terminal and as we are calculating values at leaf and go to the root, that's why we call it as the backtracking algorithm. From leaf to root, as we are going, we call it as a backtracking algorithm. Then one more important point is, we say that it is a best move strategy. Here, the min-max algorithm uses best move strategy. Best move strategy is used. That is, there will be two players. We know that two players are min and max, and always they will try to use the best move to win the game. They will have always best move to win the game. That's why the one more important point regarding this is, it best move strategy is used in min-max algorithm. Then max will try to maximize its utility. Max will try to maximize its utility. That is, it is always max will try for winning. Okay, that's why it will try to maximize its utility. Whereas coming to the one more player, min will try to minimize utility. Min will try to minimize utility. Okay, that means it will make a worst move. Worst move means not for a min. The worst move will be related to the max. Okay, max worst move try to minimize by min. That means the worst move is not to the min. The worst move is to max. It is minimizing utility means not for its turn. It is trying to minimize utility of max. That's why it always makes a worst move. So it is a backtracking algorithm. It uses the best move strategy, and max will try to maximize its utility, and min will always try to minimize its utility by making the worst move. That worst move is not to min, it is but for the max player. So see here, this is one of the example of this min-max algorithm. So if when we start the algorithm, it will total generate the game tree with the utility values. So already told you the very first point, it will start set the terminal and calculate values at leaf, and then it goes to the root. Remember, the starting will be root, there will be max. Okay. So at one level, if it is max, then in the next level, definitely we'll have a min. And in the next level max, then next level min. If there is another level, then max, then min. In this way, it is the game tree will be for min-max algorithm. So now let us start at from the utility. Now it's here. Now it's min term. Okay. Now it's a min's choice. So out of this 5 and -1, I already told you, min will try to minimize its utility. So 5 and minus 1, we know the minimum value is 1. So min will choose the minus 1. Similarly, when we have 4 and 3, min will choose 3. Minus 2 and minus 5, we know that minus 5 is the minimum value, so it chooses minus 5. Similarly, you can see here 9 and 8, 8, 6, 1, 1, minus 4, 2, minus 4, 4 and 7, 4, 3 and minus 3, 3. Okay. Now, the next one is its max turn. Now, max will try to maximize its utility. Means it is going to choose the maximum value. So, out of minus 1 and 3, we know that 3 is the maximum value. So, max will take 3. And minus 5 and 8, it will take 8. 1 and 4, 1. 4 and minus 3, 4. Okay. Now, the next one is, it is now the chances of min. So, min will obviously minimize its utility. So, out of 3 and 8, it will choose 3. And 1 and 4, it is 1. And again, coming to the root, it is now the chances for max. And 3 and 1, it uses the 3. Now, in this way, the min-max algorithm will work. So now the path is the maximum. Now the maximum is 3, 3, 3, 3. That is the maximum utility value of this particular game tree is maximum utility value is the utility value here is 3. Okay. In that way, we are going to conclude this min-max algorithm. Okay. Coming to the time complexity of this min-max algorithm is it is order of b power d. Okay, that is where b is the branching factor and d is the depth of the tree. So here we have a maximum children, so we can say that branching factor is 3 and depth you can see 1, 2, 3. It is like so it may be 8 means after the 8 moves are okay. Then uh, 8 chances we may win or lose the game. Okay? But if okay, for small things this algorithm works, but if you take any of other games like chess, so in chess an average we will have 35 moves, okay, and that is 35 branching factor where we'll have a 100 moves a player can make, that to 2 players. Okay, then just think of 35 power 100. What is the value of this time complexity? So in such cases, this min-max algorithm doesn't work well. Why? Because the time complexity and space complexity will be more, and it may go into infinity loop at some point of time. So to overcome such disadvantages, we go for next important algorithm, that is alpha beta pruning. So whatever the disadvantages or whatever the limitations we have in this min-max algorithm, that can be overcome with the help of a min-max algorithm. So when it comes to the properties of this min-max algorithm, yes, it is complete. It will definitely find a solution if there exists in the finite search tree, and it gives optimal. Okay, min-max algorithm is optimal if both opponents are playing optimally. And the time complexity, as I told you, it is order of b power m, where b is the branching factor and m is the maximum depth of the tree. Similarly, space complexity is also order of b power m. So the limitation is, the main drawback of this min-max algorithm is it gets really slow for complex games such as chess. I already told you. Okay, why? Because the depth it is and the moves the both players will make. No, that is one of the drawback of this min-max algorithm. And this type of games has a huge branching factor, and the player has a lot of choices to decide. Yes, this is what the point I said. So the limitation of this min-max algorithm can be improved with the help of another algorithm, what is important one, alpha beta pruning. So in the next class, we'll discuss about this alpha beta pruning. Thank you.